All right, so in this problem, they want us to identify the limiting reactant, and they want the theoretical yield in grams of the solid copper hydroxide. So we want grams of copper hydroxide there. All right, so I'm just going to take the information in the problem and write the quantities underneath of each reactant so I have a better visual of what's going on here. They say we have 25 milliliters of the copper sulfate. It has a molarity of 2.6 molar, which remember that molar really can be moles per liter. And for the sodium hydroxide, we have 50 milliliters, and it is 3.1 molar. But again, really think of that as moles per liter. So in determining the limiting reactant and theoretical yield, you have two methods, two approaches. So real quickly, I will show you both. And again, it doesn't matter which one you pick. It just matters you know what you're doing and you are able to show all of your work and we're able to follow that work. Method 1 involves comparing the available to the required amount. So we've calculated the available amounts of both of our reactants. Again, liters times molarity is going to give me moles of the reactant. And so that's what I've done first. I've calculated the moles of copper sulfate. We've calculated the moles of sodium hydroxide. Then I just pick one of the reactants and I solve for the other reactant required to react with that amount. So I just took the first one here, 0.065 moles of the copper sulfate. I use the mole ratio. Here's the stoichiometry part. These are our coefficients from that balance equation. 2 moles of sodium hydroxide for every 1 mole of copper sulfate. And that's going to tell me that we're going to need 0.13 moles of sodium hydroxide to react with all of the copper sulfate. And so we then compare the amount of sodium hydroxide available to the required amount. And we see here that we have a greater amount available sodium hydroxide than the required. So the sodium hydroxide is the excess reactant, which means the copper sulfate is going to be the limiting reactant. Okay, so I have now solved for the limiting reactant. This is one of my answers. And now I want to calculate the theoretical yield. The theoretical yield always depends upon the limiting reactant. So that starting amount or available amount of that copper sulfate or limiting reactant is going to determine that theoretical yield. So I take the available amount of that copper sulfate, which we already have solved for. I then use stoichiometry and that mole ratio, the coefficients from our balance equation. For 1 mole of copper hydroxide, 1 mole of copper sulfate is required, a 1-to-1 ratio. And then I just go one more step in my dimensional analysis because this problem asked me to solve for grams of the copper hydroxide, and we get a theoretical yield of 6.3 grams of copper hydroxide. So that's method number 1. Method number 2 is going to require solving for the amount of product made by each reactant. So we're doing 2 dimensional analysis grids, and we are going to compare the products produced from each one. The smaller one is going to be our theoretical yield. And so we took our first reactant, the copper sulfate. We had 0.025 liters of that solution. Here I'm using molarity in dimensional analysis because really molarity, guys, is just another conversion factor. It tells me how many moles for every 1 liter of that solution. Then I converted to moles of that copper hydroxide. Here's the stoich part. For every 1 mole of copper hydroxide, 1 mole of copper sulfate is needed. And then I go one more step and we use the molar mass to calculate the grams of copper hydroxide. So we get a value of 6.3 grams of the copper hydroxide. Now I'm going to repeat this entire process for our second reactant, sodium hydroxide. We have 0.05 liters of the sodium hydroxide solution. It has a molarity of 3.1 molar, and here's that mole ratio: 1 mole of copper hydroxide for every 2 moles of sodium hydroxide according to our balance equation. I finally multiply by the molar mass of that copper hydroxide, and we get a yield of 7.6 grams of copper hydroxide. And so I've now calculated the amount of product made by each reactant. And here comes the comparison part. You compare these two answers, and you pick the smaller one. The smaller one, the 6.3 grams of copper hydroxide, that is your theoretical yield. And then to answer the question of limiting reactant, the reactant that produces the theoretical yield is the limiting reactant. So look back at this first dimensional analysis grid. Which reactant produced this theoretical yield? That is the copper 2 sulfate solution. So therefore, copper sulfate is the limiting reactant. So again, doesn't matter which method you choose, as long as you show all of your work and I'm able to follow your thought process.